Okay, well, hello everybody, welcome. Thanks again for coming. So we're now on week 3 of a class series about building a stronger understanding of our faith beliefs by wrestling with some of these really common and difficult challenges of a belief in God, particularly a belief in the God of the Bible. So again, here's our topic schedule. I'll quickly run through some of the topics we've already discussed. So in the first week, I tried to lay out a case that a faith in God is not only rational, but is the only worldview that sufficiently addresses the biggest questions of life. We also discussed the challenges we face as Jesus followers in this current environment where the very concept of truth is under attack, thus making it more difficult to share our faith with others. Last week, we talked about the tension between faith and doubt. We used the analogy that faith was like putting your weight onto a bridge without knowing for sure that the bridge was going to hold you up. We talked about the role that evidence plays in decision making. As a Christian, we shouldn't fear the evidence, but embrace it. And we should encourage others to weigh the evidence on both sides of the case and ask them to consider what is most reasonable. Because ultimately, taking your first step onto the bridge of faith should be more like taking a leap into the light than a blind leap into the dark. Now that we've set the stage for considering the evidence, for making decisions, and why this whole endeavor is important, let's move next to looking at some of the evidence. Last week I introduced this quote from Carl Sagan, that beloved atheist astronomer who famously said, "The cosmos is all that is, or ever was, or ever will be." We're going to think deeply about this famous saying in today's class on cosmology. So cosmology is the study of the origin, development, and eventual fate of the universe. Before we go further, will you join me in a word of prayer? Dear Heavenly Father, thank you for bringing us together today and for this opportunity to congregate in your church. We pray that our awe for your greatness will be amplified today and that your Spirit will work on our hearts to have a greater reverence for your love, mercy, and power. Please bless our time together, including our thoughts and actions. Protect the words of my mouth and what is heard and believed. We commit this time to you. In Jesus' name, amen. Well, here's a rendition of the known visible universe provided by imaging from NASA. I say the observable universe because there's only so much we can detect with our current technology. One of the many wonders of astronomy is that the perception of any visible light is like looking at history. This is due to the finite speed of light. Some of the starlight we see at night has been traveling for millions of years to reach us, so long that the star that emitted that light may no longer exist. As a result, we can look back billions of years in time. Well, where are we in the universe? Here's another rendition to try and give you a sense of the sheer awesomeness of the universe. Of course, we'll start that we are somewhere here on Earth. Zooming out, Earth is part of our solar system, which is part of an interstellar neighborhood. I know it's hard to see, but wait for it. Located on one of the arms of a spiral galaxy called the Milky Way. Zooming out further, the Milky Way is part of several other galaxies in a local galactic subgroup, which is part of the Virgo supercluster, which is part of a group of local superclusters, now putting it all together with the observable universe. Here's another picture of the Milky Way, with our planet zipping along on one of the arms of the galaxy. Interestingly, that little yellow circle represents about all the stars you see at night. There are 100 billion stars in the Milky Way. Now, the average distance between those stars is 30 trillion miles. The space shuttle can go only about 17,000 miles an hour. So to go 30 trillion miles as you hop from average star to average star would take you over 201,000 years. The Milky Way galaxy is huge. The universe is unimaginably huge. Many of the Old Testament Hebrew words for God, Elohim, Adonai, El Shaddai, often stand for giant or huge or a great mountain. The universe is like God in its hugeness. It's beyond our comprehension. Here are two more pictures just to show how small we are. Here's the relative size of Earth compared to the other planets and the sun. But our sun is not very large. One of the largest stars we know of is called VY Canis Majoris. It's a red hypergiant star located in the constellation Canis Major, and it dwarfs our sun. Okay, I think I've made my point that the universe is big. Frankly, I think we need that kind of reminder often. Let's do one last picture. Here's a subsection of our interstellar neighborhood. The Oort cloud is about twice the distance from Neptune. So if Neptune is right here, that would be the Oort cloud. So you can imagine how close Earth is. Now Alpha Centauri is our nearest star. It's 4.2 light years away. That means the light we see at night from Alpha Centauri took 4.2 years of time before it reached us. Well, suppose you wanted to go see Alpha Centauri and hopped in a space shuttle, hit the hyperdrive, thus taking you 25 years to get there. When you get there, you check it out, head back in your space shuttle for the 25-year return trip. Well, how many years would have passed here on Earth while you were on your journey? Would it be 50? Who would greet you when you arrived back home? Would you see your brothers and sisters? Do you see your grandchildren, your great-grandchildren? Well, how many years would have passed here on Earth? Not 50 years, but 50,000 years. That's because you are traveling at a faster speed, and thus time moves slower for you than it did back home for us. If you saw that movie Interstellar, they tried to deal with this fascinating concept of the interrelationship between time and speed. Well, once you grasp the vastness of space and how far everything is from us, you may wonder what the point of all this space is. And I think that's a great question. But perhaps we should be asking ourselves even a more fundamental and impactful question. Leibniz stated it simply as this: in Leibniz's view, there were two kinds of things. Things that exist necessarily, and things that are produced by some external cause. Well, the second thing is easier to understand because that's just cause and effect. The first thing's a little harder to grasp at first because it means that there might be things that exist because they've always existed. Existence is part of its nature. Let's walk through a simple version of the cosmological argument for the existence of God. It goes like this. Everything that exists has an explanation of its existence. The universe has an explanation of its existence. That explanation is God. The universe exists. If you were going to refute this argument, you'd likely attack that second premise, that there are or could be other explanations for the existence of the universe. Let's go to a version of this argument that doesn't name God and might be better in your discussions with your skeptical scientific friends. It's called the Kalam cosmological argument, and it goes like this. Whatever begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. This is a simple, easy to remember argument. Most scientists wouldn't dare attack the first premise because that's the law of causality. To doubt the law of causality is to doubt virtually everything we know about reality, including our ability to do reason and do science. All arguments, all thinking, all science, all aspects of life depend on the law of causality. Most scientists wouldn't dare attack premise 2 either, since that deals with the Big Bang. And as we'll cover in today's class, there's a lot of great scientific evidence out there supporting the Big Bang. Well, if this argument holds, then there are some interesting implications, such as I think you can deduce the existence of a self-existent, uncaused, timeless, spaceless, immaterial, powerful, intelligent, and personal creator of the universe. Okay, well, let's bring back our skeptic that we introduced last week, who will be making several appearances in this class as represented by this Goofy Simpsons character. He says, well, if God exists, then who created him? Well, this is kind of a classic knee-jerk reaction, objection to the cosmological argument. It's an old argument that Richard Dawkins brought back to life in his 2006 bestseller, The God Delusion, as if he can't conceive of anything that could be eternal. Well, science does not tell us that there's nothing eternal. In fact, if there wasn't anything eternal, then Dawkins is implicitly conceding that the universe came out of nothing. But don't let me get sidetracked here. So how should we respond to this objection? Well, let's go back to the law of causality. The law of causality does not say that everything needs a cause. It says that everything that comes to be needs a cause. Remember, the first premise of our argument was whatever begins to exist has a cause. Well, God did not begin to exist, and he was not created. He exists necessarily. Well, perhaps a good analogy here is numbers. They're not caused to exist by something else. They just exist by the necessity of their own nature. God does not require outside support to exist. God cannot be created, nor can he cease to exist. And God cannot create another God. That would be nonsense. You can't create a God that has the attributes of God, like omnipresence or eternality. It would be logically impossible, just like creating a round square. It's nonsense. All right, he's not done. Okay, but what if the universe is eternal? Then nothing created it. Well, the response is yes, it is logically possible that the universe is eternal and did not have a cause. If you're a math person, though, you might want to take note of this topic for future study. There's some really interesting discussions about why an eternal universe does not make logical sense, because it relies on an infinite regress of actual events in time and space. I know, that's a tough one, so I'll come back to that shortly. But for now, and for the sake of argument, let's just assume that an eternal universe is logically possible as one of two possibilities. Either the universe is eternal, or something outside the universe is eternal. So let's look at the evidence. Let's take the walls in this room, for example. Here are 4 possible reasons for the existence of the walls in this room. Number 1, it's an illusion, a figment of your imagination. Are we all living in the Matrix? Are these walls an illusion? There's not many people in the world that would think these walls were an illusion. But if you did think this, then you still need to answer the question, what is having the illusion? In order for there to be an illusion, something must exist to have the illusion. An illusion can't have an illusion, because an illusion is not a thing. Something must have the illusion. Well, the great René Descartes wrestled with this question exhaustively, ultimately determining that this was not an illusion, and thus the famous, I think, therefore I am. All right, number 2, the walls are self-existent and eternal. The walls weren't made, they didn't grow, they weren't born. Since the beginning of time, these walls existed. Option 3, the walls created itself out of nothing. The walls mysteriously came into being by itself. But these walls can't create themselves. Nothing can create itself. That would violate the law of non-contradiction. Well, since the law of non-contradiction seems to be maybe the most violated law in the public and scientific arena right now, let's just do a quick recap. The law states that something cannot be A and not A at the same time and in the same relationship. For example, can a woman be a mother and a daughter? Well, sure, but not at the same time and in the same relationship. She can't be her own mother, in other words. So pretty easy, right? Well, what about the walls creating themselves? If the walls were going to create themselves, then they'd have to both exist and not exist at the same time and in the same relationship. So something that does not exist can't, at the same time, create something that exists. It would have to exist first to create something that exists. All right, number 4 is the walls were made by someone other than itself. So if these are the 4 options, and I would challenge you to consider or think of other possibilities that don't fall under these 4, then nearly everyone will agree with number 4, that the walls were made by someone other than itself. Indeed, if anything exists at all, then something somewhere must have the power to make whatever is here be here. Thus, something must have the power of being. But let's go back to the universe. In looking at this list, we can see where the atheistic scientific community wants us to believe. They want us to think that the universe created itself, that the universe caused itself to come into being, or that the universe came into being by chance. You can park that claim of chance in your minds. We'll come back to it later. Okay, let's talk about the evidence for the creation of the universe. 100 years ago, most scientists assumed that the universe had no beginning and no end. This was called the steady state theory. It was so widely accepted that even Einstein put a fudge factor into his theory of relativity in 1916 so he could maintain the steady state theory. He would later call this the greatest blunder of my life. So the Big Bang is relatively new science. Well, what is the Big Bang? Well, if you could watch a video recording of the history of the universe in reverse, you'd see all matter collapse back to a point that is actually nothing. That is, no space, no time, no matter. In other words, once there was nothing, then bang, there was something. Although the number keeps getting adjusted, our best science seems to indicate that the Big Bang happened approximately 14 billion years ago. We'll next discuss several forms of evidence about the Big Bang. If you're wondering how we can talk about 14 billion years in comparison to the number of days and years mentioned in the book of Genesis, I'll be spending time on that topic next week on our class on evolution. We'll briefly cover all 5 of these forms of evidence for the Big Bang. To remember them, you can use this acronym SURGE, which stands for the first letter in each of the numbers listed. Okay, let's talk about the first one, the second law of thermodynamics. We're going to take a quick trip back to your high school physics class. Thermodynamics is the study of matter and energy. Okay? In high school, you were probably forced to remember the 3 laws of thermodynamics. Let me just list them quickly here, and we'll focus on the second law. Don't worry, there won't be a quiz. The energy in a physical system can be neither created nor destroyed. A closed system will tend toward increasing disorder or entropy until it reaches equilibrium. As a system approaches the temperature of absolute zero, its entropy approaches a certain minimum value. Well, many scientists hold that the second law is the most established law in all of nature. Here's a quote from the great astrophysicist Sir Arthur Eddington. The law that entropy increases, the second law of thermodynamics, holds, I think, the supreme position among the laws of nature. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There's nothing for it but to collapse in deepest humiliation. Okay, so it's a well-documented law. But what does it have to do with the Big Bang? Well, basically the second law says the universe is running out of usable energy. In other words, unless energy is constantly being fed into a system like the universe, the processes in the system will tend to run down and quit. Eventually, all the heat and energy in our universe will be dispersed. Once it reaches such a state, no significant further change is possible. Scientists call this the heat death of the universe. It will eventually become a thin gas of subatomic particles, endlessly expanding in absolute darkness. For example, at 10 to the 30 years, the universe will consist of 90% dead stars, 9% supermassive black holes, and only 1% atomic matter, mainly hydrogen. If this is the likely future of the universe, then you may be tempted to ask the following question. If the universe had always existed, then why aren't we now in a state of heat death? Given an infinite past, then we should be in the heat death state right now. But we're not. Therefore, the universe had a beginning. Okay, if that's hard to get your head around, then let's do another analogy, this time of a car. There's a finite amount of gas in your car, the first law, and you're running out of gas, the second law. If your car had been running from all eternity, it would be out of gas now. But since you still have some gas in the gas tank, the car must have started to run at some point. In other words, it had a beginning. The U in the acronym SURGE stands for the universe is expanding. In 1929, Edwin Hubble looked at the rate at which our neighboring galaxies were moving away from us. Using the Doppler effect, the same principle that allows the police to see how fast your car is going, Hubble found that the light from those galaxies was skewed red, implying they were moving away at great speeds. And the farther away the galaxy, the faster the galaxies were receding. The universe was expanding. If everything in the universe is flying apart, then reversing the arrow of time would predict that at some point all these galaxies were together in one incredibly massive entity. Here's some quotes about this discovery. For the theory that fits our data, the universe will expand forever. The idea of the expansion of the universe was absolutely beyond comprehension. Throughout all of human history, the universe was regarded as fixed and immutable, and the idea that it might actually be changing was inconceivable. Of all the great predictions that science has ever made over the centuries, was there ever one greater than this? To predict, and predict correctly, and predict against all expectation a phenomenon so fantastic as the expansion of the universe? Let's go into the R. The R stands for the radiation from the Big Bang. Well, by 1948, a handful of scientists had predicted that if the Big Bang did happen, then the radiation from the explosion would be detectable. In 1965, Arno Penzias and Robert Wilson, two technicians for Bell Labs, detected strange radiation from their giant antennas, no matter which direction they pointed it. They originally thought it was bird poop from pigeons, so they scraped it clean, but the radiation was still there. Essentially, what they discovered was the echo or afterglow of the Big Bang. Now called the cosmic background radiation, it's essentially the light and heat from the initial explosion. They won the Nobel Prize for this discovery. Here's the first of a couple quotes I'll be taking today from Robert Jastrow, the founder of NASA's Goddard Institute of Space Studies. He said this: "No explanation other than the Big Bang has been found for the fireball radiation. The clincher, which has convinced almost the last doubting Thomas, is that the radiation discovered by Penzias and Wilson has exactly the pattern of wavelengths expected for the light and heat produced in a great explosion. Supporters of the steady-state theory have tried desperately to find an alternative explanation, but they have failed. At the present time, the Big Bang theory has no competitors." Well, for those of us old enough to remember life before cable and wireless TV, we used to fiddle around with those goofy antennas on top of the TV called rabbit ears. Well, even those little antennas could pick up the cosmic microwave background. About 1% of the snow you would see on Channel 3 detected that radiation. Let's go to the G. Well, if the Big Bang did occur, scientists predicted there would be ripples in the temperature of the cosmic background radiation. These temperature ripples enabled matter to congregate by gravitational attraction into galaxies. In 1989, NASA launched this, the COBE satellite. It stands for Cosmic Background Explorer. Its main objective was to search for evidence of the ripples. NASA not only found the ripples, but were astonished by their precision. The ripples showed that the explosion and expansion of the universe was precisely tweaked to cause just enough matter to congregate to allow galaxy formation, but not enough to cause the universe to collapse back on itself. The ripples were so exact that the COBE project lead called them, quote, "the fingerprints of the maker." If you've ever seen these blue and green radiation drawings of the universe, they came from the COBE satellite project. Here are a couple quotes from about the project's findings from these two guys. Of course, the guy on the left is Stephen Hawking, who said this about the detection of the temperature ripples in the cosmic background radiation: "The most important discovery of the century, if not of all time." And here's a quote from the guy on the right, George Smoot, the head of the COBE project: "If you're religious, it's like looking at God. And one last quote from astrophysicist Michael Turner, who said, "The significance of this discovery cannot be overstated. They have found the holy grail of cosmology." Let's go to the E. This is the last letter in our SURGE acronym. It stands for Einstein's theory of general relativity. Well, general relativity is a theory of gravitation that was developed by Albert Einstein. According to general relativity, the observed gravitational effect between masses results from their warping of space-time. Einstein's theory shows that time, space, and matter are interdependent. In other words, you can't have one without the others. One could therefore conclude that there must have been an absolute beginning for time, space, and matter. And if so, then the universe must have had a cause that transcends the domain of space, time, and matter. The theory of general relativity has been scientifically verified to the 5th decimal place. Here's some quotes about the Big Bang. The first one is a really good one about the reluctant adoption of the theory. At first, the scientific community was very reluctant to accept the idea of a birth of the universe. Not only did the Big Bang model seem to give in to the Judeo-Christian idea of a beginning of the world, but it also seemed to have to call for an act of supernatural creation. It took time, observational evidence, and careful verification of predictions made by the Big Bang model to convince the scientific community to accept the idea of a cosmic genesis. The Big Bang is a very successful model that imposed itself on a reluctant scientific community. And one more from Eddington. The beginning seems to present insuperable difficulties unless we agree to look on it as frankly supernatural. Let me just quote again from Robert Jastrow, the founder of NASA's Goddard Institute of Space Studies, who said this about the Big Bang. Now keep in mind, he's an agnostic. He says, "Astronomers now find that they have painted themselves into a corner because they have proven by their own methods that the world began abruptly in an act of creation to which you can trace the seeds of every star, every planet, every living thing in the cosmos and on Earth. And they have found that all this happened as a product of forces they cannot hope to discover. That there are what I would or anyone would call supernatural forces at work is now, I think, a scientifically proven fact." Elsewhere he says, "Now we see how the astronomical evidence leads to a biblical view of the origin of the world. The details differ, but the essential elements in the astronomical and biblical accounts of Genesis are the same. The chain of events leading to man commenced suddenly and sharply at a definite moment in time, in a flash of light and energy." Well, now that we've presented some compelling evidence for the evidence of the Big Bang, let's address some common objections. Couldn't the universe have started by chance? For those that want to leave God out of the picture, the claim that the universe started by chance is perhaps the most commonly used description of the cause of the universe. Not only the layperson and the popular media have stated this claim, but also very learned scientists. So what is chance? Well, chance is a word we use to describe probabilities. Chance is not a thing. It can't cause anything to happen because it has no power to influence anything. Nothing can happen by chance. Chance can't do anything because it's not a thing. It has no being and no power. So what are the chances that anything can happen by chance? The answer is not a chance. Chance is a perfectly good word to talk about probabilities, but it can't actually do anything by itself. Many have claimed that chance is the most abused term in science today. In order for chance to do something like create the entire universe, it must first exist or have being. But chance, again, is not a thing that exists. It has no matter, no energy, no power, no being, and therefore it can't influence anything. If you recognize the underlying flaw in this objection, then you know that what I just described has to do with the law of non-contradiction. Chance can't be and not be at the same time and in the same relationship. How about some other theories? Well, why couldn't natural forces have produced the universe? Even the great Stephen Hawking has made bold but not well supported claims such as this. He said, "God may exist, but science can explain the universe without a need for a creator. Well, in response, we need to go back to saying science has shown that natural forces, indeed all of nature, were created at the Big Bang. So how can Hawking say that science can explain the universe before the time where the tools of science even work? Remember, science only measures the physical things within nature, but nature started at the Big Bang. So how can it explain the cause of nature? Nature was the effect, so it can't also be the cause. Therefore, there must be something outside of nature, that is supernatural, that did the job. But our skeptic is not done yet. He may retort with this following objection. Well, what about other universes, baby universes, inflationary multiverses, imaginary time? What about oscillating models, vacuum fluctuation models, chaotic inflationary models, quantum gravity models, and string scenarios? Well, fortunately for me, there's not enough time to explain and address each of these objections. There are a lot of theories out there about what happened before the Big Bang, yet science can never go any further back than the moment on which the laws on which it stands began to operate. Edgar Andrews, the emeritus professor of materials at the University of London, seems to concur. He says, "Science, even at its most speculative, must stop short of offering any explanation or even description of the actual event of origin." However, don't expect the scientific community to cease their discussions about the cause of the universe. It represents a great mystery, and thankfully, scientists love unsolved mysteries. But at this point, these alternative proposals are extremely speculative in nature, with little or no supporting data. If you attended last week's class, then you may recognize these other theories as belonging to the category of either possible or imaginary doubts. As we discussed last week, there will always be unanswered questions. Just like in a jury room, our task is to separate reasonable doubts from those that are possible or imaginary, so that we can make a decision based on the evidence that is beyond a reasonable doubt. Well, it seems as though one of the biggest challenges we face with contemplating the origin of the universe has to do with understanding what nothingness is and what it isn't. So what existed before the Big Bang? If the Big Bang was the start of space, time, and matter, then nothing existed before it. Well, nothing is not just empty space. Nothing is the absence of anything whatsoever, even space itself. It is not a sea of fluctuating energy, as some scientists have postulated. Nothingness is also not a super dense pellet of material existing in empty space. Nothing is absent of time, even Stephen Hawking's imaginary time. So what can nothingness do? If there ever was a time when there was nothing, absolutely nothing, what would there be now? Nothing. If you've ever heard the phrase ex nihilo nihil fit, it means out of nothing, nothing comes. You can't get something from nothing. Although this has always been one of science's most firmly held beliefs, for whatever reason, scientists see no inconsistency in their belief that the entire universe can create itself out of nothing by chance. You may be tempted to ask these people the following question, but don't expect a good answer. If the universe can come into being from nothing, then why doesn't anything and everything come into being from nothing? So it might make you scratch your head when you hear a series of phrases like that of Peter Atkins, an atheist professor of chemistry at Oxford, who claims that the entire universe is an elaborate and engaging rearrangement of nothing, in which space-time generates its own dust in the process of its own self-assembly. Well, I can't make heads or tails of that one. So let's transition now from speculations about the start of the universe to the observations we actually see in the universe. Let's take a cue from William Paley's famous watchmaker analogy. He wrote this 200 years ago. In crossing a heath, suppose I pitched my foot against a stone and were asked how the stone came to be there. I might possibly answer that, for anything I knew to the contrary, it had lain there forever. But suppose I had found a watch on the ground, and it should be inquired how the watch happened to be in that place. I should hardly think of the answer which I had before given, that for anything I knew, the watch might have always been there. The watch must have had a maker, that there must have existed at some time and at some place or other an artificer or artificers who formed it for the purpose which we find it actually to answer. Who comprehended its construction and designed its use? Every indication of contrivance, every manifestation of design which existed in the watch exists in the work of nature, with the difference on the side of nature of being greater or more, and that in a degree which exceeds all computation. Here's the very brief and easy to remember argument from design. It's also known as the teleological argument. It goes like this. Every design had a designer. The universe has highly complex design. Therefore, the universe had a designer. Here are just two quick quotes about design from a macro and micro level. Here's the macro level quote from Isaac Newton about the universe. This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. And here's the micro level quote from Stephen C. Meyer about DNA. Intelligence is the only known cause of complex, functionally integrated information processing systems. In other words, science has no examples in which information came from anything other than an intelligent source. In other words, DNA bears the marks of design. We'll talk much more about DNA in next week's class, but today's class is about the macro level, so let's look at Newton's claim that design is apparent in the universe. The universe appears to be specifically fine-tuned to enable life on Earth. Earth, a tiny oasis in a vast and hostile universe. One of the ironies of history is that the phrase anthropic principle first appeared in Brandon Carter's contribution to a 1973 symposium honoring Copernicus's 500th birthday. Carter, a theoretical astrophysicist, articulated the anthropic principle in reaction to the Copernican principle, which states that humans do not occupy a privileged position in the universe. As Carter said, although our situation is not necessarily central, it is inevitably privileged to some extent. There's two kinds of fine-tuning: the constants of nature, so that's gravity, electromagnetism, the strong and weak subatomic force, and then arbitrary physical quantities. Let's just go through a few examples. Actually, before we go through examples, let me give some context around really, really large numbers. So the number of seconds in the entire history of the universe is 10 to the 17th. And the number of subatomic particles in the known universe is 10 to the 80th. So that's a 1 with 80 zeros after it. Okay, just giving you those for context. So with those in mind, let's do an example of fine-tuning. So a change in the subatomic weak force, which operates inside the nucleus of an atom by even 10 to the 100th, would have prevented life in the universe. A change in the cosmological constant, which drives the acceleration of the universe's expansion by even 10 to the 120th, would have prevented life in the universe. If the gravitational force were altered just slightly, our sun would not exist. Oxygen. It comprises about 21% of the atmosphere. If it were, say, 25%, then fires would erupt spontaneously. If it were 15%, we'd suffocate. If carbon dioxide levels were higher, we'd burn up in a greenhouse effect. If they were lower, we'd suffocate because plants would not be able to maintain photosynthesis. Moon-Earth gravitational interaction. If there were greater tides, the atmosphere and the rotation period would be too severe. If it were less, orbital changes would cause climate instabilities, making life on Earth impossible. If the Earth was slightly smaller, it would lose its internal heat and couldn't keep its interior core active. If the Earth was slightly larger, it would have too much water and too thick of an atmosphere. I'm just going to list a few others, but there are 122 of these. The thickness of the Earth's crust, Earth's rotation and axis tilt, the speed of light, water vapor levels, the amount of lightning and earthquakes, Jupiter's size and orbit, which prevents asteroids from hitting Earth, So there's with so many of these conditions that have to be just right for the universe and Earth to permit life, it led astrophysicist Fred Hoyle, the same man who coined the term Big Bang, to make the following statement. The chances that life just occurred on Earth are about as unlikely as a typhoon blowing through a junkyard and constructing a Boeing 747. Well, Stephen Hawking has spent a lot of time studying the apparent fine-tuning of the universe. Here are some of the comments that he's made. He said, "Why did the universe start out with so nearly the critical rate of expansion that separates models that recollapse from those that go on expanding forever? That even now, 10,000 million years later, it is still expanding at nearly the critical rate. If the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, the universe would have recollapsed before it ever reached its present size. If the density of the universe 1 second after the Big Bang had been greater by 1 part in 1,000 billion, the universe would have recollapsed after 10 years. On the other hand, if the density of the universe at that time had been less by the same amount, the universe would have been essentially empty space since it was about 10 years old. How was it that the initial density of the universe was chosen so carefully? Maybe there is some reason why the universe should have precisely the critical density." Well, Hawking has been no friend to those of the religious faith, but yet he made these 2 other comments. It would be very difficult to explain why the universe should have begun in just this way, except as the act of a God who intended to create beings like us. The odds against a universe like ours emerging out of something like the Big Bang are enormous. I think there are clearly religious implications. Here are just a couple more quotes about fine-tuning. Francis Collins, the head of the Human Genome Project: "The existence of a universe as we know it rests upon a knife edge of improbability. The more I examine the universe and the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. The best data we have are exactly what I would have predicted had I nothing to go on but the 5 books of Moses, the Psalms, the Bible as a whole." Well, that last one's from Arno Penzias, who was the Nobel Prize winning co-discoverer of the cosmic background radiation. He says elsewhere, "Astronomy leads us to a unique event, a universe which was created out of nothing, one with the very delicate balance needed to provide exactly the right conditions required to permit life, and one which has an underlying, one might say, supernatural plan." Our final quote on fine-tuning comes from Professor Paul Davies, who said, "I cannot believe that our existence in this universe is a mere quirk of fate, an accident of history, an incidental blip in the great cosmic drama. Our involvement is too intimate. We are truly meant to be here." Okay, let's tackle some objections. Isn't this circular reasoning? The universe had to have these exact parameters, or we wouldn't be here to observe them. Well, there's 3 possibilities for the fine-tuning of the universe. One would be physical necessity. In other words, the constants and quantities must have the values they do. The universe has to be life-permitting. It's a necessity, or in other words, a universe without life is not physically possible. Well, but there's no evidence for this. On quite the contrary, it seems that a life-prohibiting universe is far more likely than a life-permitting universe. Design. The precise tuning of all the physical constants and laws to make intelligent life possible is not an accident, but reflects the action of the one who created the universe in the first place. If there's a God, then this option makes the most sense. And finally, chance. It's just an accident that all the constants and quantities fell into the life-permitting range. We just lucked out. Or maybe there are infinite universes, and this is the one that has life. Well, the multiverse idea has garnered quite a bit of speculation recently, so let's explore that one a bit further. Here's the objection. There are trillions of universes existing over enormous amounts of space and time. It is inevitable that some of them are fine-tuned to sustain our kind of life. Design is an illusion, and therefore the possibility of a designer is delusional. Well, of course, Dawkins made this claim in his book, The God Delusion. Our response is, frankly, we have to agree that the multiverse idea is possible, but there's no shred of proof that they exist. There's also no way to prove that they don't exist. Well, like a scientist, we must ask the question, is the multiverse theory the best fit of the available data? For those that may hold this view, the multiverse theory does not address why anything exists at all, or does it address the biggest questions of life? And even if there are multiple universes, there's still the question why there's something at all rather than nothing. They've just moved the question one step further. In other words, they haven't explained away the need for a creator. It would take a lot of faith to believe that this is the explanation behind the Big Bang and everything else that exists, even the things that exist in other universes. Let's conclude the teleological argument. Every design had a designer. As verified by the anthropic principle, we know beyond a reasonable doubt that the universe is designed. Therefore, the universe had a designer. Well, although we haven't eliminated all possible or imaginary doubts, again, those are topics we discussed last week, I think the evidence behind the apparent design of the universe is compelling enough to say, beyond a reasonable doubt, that the universe was created and designed by a designer. Author Patrick Flynn summed it up well. He said, "Today, the concrete data points strongly in the direction of the God hypothesis. Those who wish to oppose it have no testable theory to marshal, only speculations about unseen universes spun from fertile scientific imagination. Ironically, the picture of the universe bequeathed to us by the most advanced 20th century science is closer in spirit to the vision presented in the book of Genesis than anything offered by science since Copernicus." Before I state some concluding remarks, let's think back to how massive the universe is. Imagine the distance between Earth and Sun equal the thickness of a sheet of paper like this. Again, distance between the Earth and the Sun. That would make the distance between the Earth to our nearest star equal to a stack of paper 70 feet high. That would make the distance between the Milky Way, across the Milky Way galaxy, equal to a stack of paper 310 miles high. The Milky Way is just one of billions of galaxies. Imagine there's a God who holds all this together with a word of his power. If God exists, then he is supernatural. If he is supernatural, then he's not limited by natural laws. He exists apart from matter, time, and space. If he is not limited by natural laws, there's no reason he should be limited by time. If he's not limited by time, then he's in the past, the present, and the future. Thus, he could exist before the Big Bang, and he could exist after the universe fades away, if it ever does. He could know the precise outcome of the formation of the universe even before it started. He could have foreknowledge of a planet near the outer rim of an average spiral galaxy that would have just the right characteristics to allow life. Well, in today's class, we wrestled with the following big questions. To address these questions, we explored some of the evidence for the existence of the universe through Big Bang theory, the evidence for fine-tuning and design, and logical arguments for the existence of a creator. And we obtained quotes from several of the top minds in astrophysics. If this is a good representation of the available data, then what is the best explanation for the data? Well, non-believers claim that the universe just exists as a brute fact, that it created itself out of nothing by chance. But this seems to fill in the blanks without a real explanation of the why or how questions. For the why question, the answer for the atheists appears to be that it's just a massive coincidence, that life is an accidental byproduct of an undirected and unpurposed universe that came from nowhere and is heading toward oblivion. On the other hand, Christians find that God seems to make sense of Leibniz's question about why there's something rather than nothing. It seems to explain why the fine-tuning of the universe is so precise, and why nature and the universe itself seems to be written in a mathematical language, almost as a fingerprint that God left behind for those investigators who wish to find him. The order, elegance, and majesty of the universe, and our existence in it, seems to be crying out for an explanation beyond itself. Since space, time, and matter had a beginning, we know that the cause can't be made of space, time, or matter. The conclusion that there is a spaceless, timeless, immaterial, powerful, and personal first cause flows logically from the evidence itself. If you add to that the seemingly miraculous design and fine-tuning that allows us to even have this talk today, then I think the case is incredibly compelling that the universe had a creator and a designer. Thank you very much.